So I had this issue where my ICOM IC-756PRO transceiver stopped transmitting, and I watched a number of videos on YouTube, and many suggested that there could be a pre-driver IC underneath there. But I had an oscilloscope and I traced it. I saw that the transmitting signal that comes to the power amplifier, it comes through here. So I saw it, putting the transceiver into FM mode and pressing transmit. So I certainly was getting some signal here. And I traced this pre-driver. I watched the signal coming through there. And then the driver, that's where it stopped. The driver transistors were not responding. And so I set out to replace those. And this is where this saga, this story begins. So this is the transistors that I needed to replace. I measured the signal coming through here. It was going through this pre-driver and going to the bases here, but nothing was coming out. And so I figured, okay, so this is the transistor that I had to replace. And I started searching for them, and there were plenty of them available. Surprisingly, I thought, oh, okay, great. So I ordered a couple. And so I received this transistor here. And immediately there was this suspicion. Something was amiss. So this is the transistor that I got, and this is the transistor that I unsoldered, the one that was faulty, the genuine Mitsubishi one. So you can see the print is different, the Mitsubishi sign is different, the way they are arranged is different. Well, I thought, what the hell? Maybe it's a transistor is good enough, you know. Maybe it's a substitute. So I set out to test it with a tester. So I stuck it in. So then it came up with HFE 145 at 6.3 milliamp. Well, at least it is a transistor of sorts. Okay, what the heck. When I looked at the specification online, what stood out immediately is that the HFE, the gain was way, kind of hovering at the upper edge, but this gain was measured at approximately 100 milliampere, not at 6.8, not at 7 milliamp. And when you look at the actual curve at around 5 milliamp, it's supposed to be around 40, not 140 something. So on average, it's supposed to be here. Well, anyway, so that was another suspicion moment. And then I put them in. And here what happens. Immediately, the moment they were switched on, they popped like a balloon on a hot summer day. Both of them together. Here. And then what I noticed also that the actual die, so it's a bit difficult to open. Right, here we go. So what I noticed is that the actual die is quite small there. Out of curiosity, I opened the original one, and as you can see, the difference. This is the silicon. The rock is quite large comparing to this. It's like day and night. So these ones are definitely, they are not designed to withstand the power rating of this the original transistor. And that's where this Pandora's box opened. These transistors are unobtainium. It's very difficult to they've been stopped. They're not manufactured. It's very difficult to find them. It's impossible to find them. There's plenty you can find them on eBay or AliExpress or Alibaba. And you're gonna get them, but they're gonna be like this. They're gonna be like this, all of them. And what do? So I decided to switch to the field transistor. So you see, my version of the transmitter is 756PRO, but in 756PRO 3, here, you see that the driver, the pre-driver transistor right here, is still 2SC1971, but the driver transistors are field transistors, JFET. They switched to RD15HVF1. And so I decided, okay, I need to do this. But they are quite different from when you need to bias them from the NPN transistors here. So there were a number of modifications that needed to be done. First off, on this schematic, and by the way, on the schematic of 756PRO 2, there is a mistake. So this one is supposed to go here in order for the power amplifier to work. This one is not the right spot. But then I need to bias these transistors differently. So if they're going to be switched to JFETs, the bias needs to be around 3 volts. See, the biasing here is around 0.68. I need to increase the bias to about +3. So for this, the following needed to be done. These two resistors had to be changed to 2.2 kilo ohms, both of them, from 74 ohms to 2.2 kilo ohms. And here you need to take down this diode, so because we're not going to use it as the voltage drop anymore. And then we need to introduce another port, resisting port here, which would be at around 5K. And so that way we can approach around +3 volts here when this transistor is going to be replaced. So that's what I did. That's what I did. And as I said, I did just that. I replaced those transistors. Here they are. This and this. And as you can see on markings, they are RD15HVF1. And this is the variable resistor here, which is in line with the one that was put there before, well, the original one. And multi-turn, it's a good idea, was to put the multi-turn variable resistor, which made the adjustments a bit easier. And also I replaced the SMD components there, this and this. Remember, they needed to be changed from 47 ohm to 2.2 kilo ohm. And also remember the diode. So the diode was sitting here, and I just removed it as well. And so this has been done. And by the way, the power transistors here, they were blown as well. So I had to take them down for now. But I'm going one step at a time. So this has been done, and let's see how it performs. So the transmitter is set at 14.1 megahertz, and I switched it into FM mode. I'm going to test first if I'm going to see anything on the screen at all. So hit transmit, yes, we do see the signal here popping up. And now I'm going to measure the signal on the base of the pre-driver first, what's coming in, and hit the transmit. And you can see on the oscilloscope here, we're getting about 360 milliwatts. This is at 5 watt power. So I set it to 5 watt. The entire transmitter is set to 5 watt. I'll make sure that I'm not getting any surprises. So we're getting about 363 millivolts. Then I'm gonna measure what I'm getting at the pre-driver output. And now we see we're getting about 2 volts already, so its pre-driver is working. Then I'm gonna check what we're getting at the input of the GFETs, the drivers, right here. As you can see, yes, we're getting, because it's going through the transformer, we're getting 500 milliwatts there. And at the output of the drivers, right here, we're gonna go back there. I'm getting about 6.2 volts. So this is what I'm expecting. As you can see, it's yeah, it's about 14.1. It's about 14.1 megahertz. So this is about it. The final transistors, I'm going to make another video. They're not there. They also were blown up. They're not there. They're going to be replaced, and for that it's going to be another video. So far, as you can see, as I already told you, there is this potentiometer, the GFETs here, and all seem to be functioning normal. And I set the bias according to the specs, which is about 3 volts. And they're giving me about 8 volts at 5 watts, so which is fair enough. Until then, goodbye.